All right, so today we're going to be talking about linear measure and line segments. So let's dive right in. Okay, so if we read the intro, it says if Alex and Luke are running a race, when Alex is at mile 4 and Luke is at mile 7, how far apart are they? Okay, what's their distance apart? And I betcha you would say 3 miles. Why? Well, because he has to get to 5, 6, and then 7, and then he will get there. So if you subtract the two locations, okay, if you subtract the two locations, then you're going to get a distance between things, okay? How far apart is your age from your parents' age? Okay, well, how much older are they? What's your distance from your parents? Well, then you would subtract your parents' age, which could be like 35 and your age, and then, okay, you're 20 years apart or something. Okay, so you can subtract those locations. And this also works on a number line with positives and negative numbers. And so if you're trying to figure out a distance between 2 points, points A and B on that picture right there, you take their two locations and you put a subtraction sign between them, okay? And then you would find their absolute value, okay? Because we don't want a negative distance. That's kind of weird, okay? So an absolute value is once you've done that adding or subtracting property, then you make your final answer positive, okay? To find the length between two things, because we don't want a negative length, okay? Directionally speaking, we could go positive or negative, but we want a distance to be a positive length, okay? So we write down the two locations, and then we put a subtraction sign between them. So the locations that I see here would be, we're going to do A, and we're going to do location of B, and then we're going to put a subtraction sign, and we'll take the opposite value of it. Okay, so the location of A is -3. The location of B is 1. And then what do we put between them? A minus sign, okay? So if you get a minus and negative, then make it plus a positive, absolutely. Do the math of those two values now that you put a subtraction sign between their two locations, and then take their absolute value. So do it in that order, do PEMDAS. So it says we do in the grouping symbol, write down the two locations, put a subtraction between them, do the math, -3 and -1 makes -4. What's the absolute value of -4? It is 4. So it'd be 4 units apart. Now, if you count this, you're like, oh yeah, 1, 2, 3, 4. Oh, I had to take 4 steps to get from A to B. Again, you don't count A. You know, as you're walking, you're like, I took 1 step here. Okay, you took a step to get there. Here's your body. Okay. Ooh, took 1 step here, took another step to get to this place, a 3rd step, and then a 4th step. So write down those two values. You could also take it the other order, because when you're finding the distance between things, if you took B and you took A and then put a subtraction between them and then took their opposite value, you're going to get the same exact answer. So B is 1, A is -3, and then what do we have to put between them? A subtraction sign. So we add a subtraction sign between them, and so we get 1 minus a -3, minus a negative, yes, it still does become plus a positive. So 1 and 3 make 4. The opposite value of 4 is still 4 units away. So write down the locations using positive or negatives as appropriate of B and A, put a subtraction sign between those two values, do the math, and then take an opposite value of your final answer. So that'll give you that distance between those two locations. So distance and length, we're going to talk about that. The length of the segment AB, okay, the segment from A to B and every point in between them, the distance between A and B, we find it by doing A minus B and then doing the opposite value, or B minus A and then the opposite value. So, okay, what about this? Okay, AB with a segment on top of it is actually the segment itself, okay? It's basically comprised of all the points, the infinite remaining points between the points A and B. Okay, so if I say, oh, segment AB, I mean point A, point B, and every point in between it. Okay, segment AB. Okay, that's the actual figure. If, however, I put M of AB, or just I write the letters A, B, okay, points A, B, that means the distance or the measurement, the length of A to B. Okay, so if I want to talk about the segment itself, I would say A to B and all the points in between it. If I would say the length of it or the measure of it, I would put one of those two blue things there. Okay. And so we can find its length, find its measure, and then we can do math with those values. Okay, so we are going to be solving equations today, kind of exciting. But I want you to know, hey, AB with a segment over it means a segment. The measurement is a numerical value. Okay, so A to B or measure of AB, segment AB is a number. Okay, and you'd be like, oh, 4 units, 5, 5 inches, etc. Okay, now here's a new concept. It's a good one, okay? It's called congruent, okay? So we know equal. Numbers can be equal. Equations have an equal sign in them. Congruent means something very specific to geometry, okay? So congruent means that, and here's how you do it. You put an equal sign with a little hill over it, okay? And so congruent means that the items have shapes, figures have the same shape and size. Okay, so it's not equal. Numbers are equal. Okay, equations have an equal sign in them. Figures are congruent if they have the same shape and they're the same size. Okay, so if your mom makes cookies and she gives you and your brother, cookies, if they're congruent, then you feel fair about it. Okay, if you get a little tiny one and your brother gets a very large one, that's not congruent cookies. Okay, and somebody's going to get hurt. Okay, wait, sorry. And so the thing is that the measurements, again, if I say AB, I mean the length of AB, okay, the distance between A and B. So the length from A to B can equal the length from D to E, okay? They might be like 5 inches, okay? So numbers are equal, but segments and shapes can be congruent if they're the same shape and size. So there's some overlap in the concepts, but I think as we get bigger, it'll help you. Okay, so if they're equal, then they will be congruent. Okay, if shapes are congruent, then they'll be equal in size. Okay, so there is some overlap. It's just kind of how we talk. Let me show you a little bit better. Okay, you would not say that triangles are equal. No. You could say, oh, the length of corresponding sides are equal in length. Okay, their angles could be, corresponding angles are going to be equal in size. They're both 50 degrees. But you would say the triangles themselves are the same shape and size as each other, if they are. Okay, so triangle ABC and triangle DEF could be congruent because they're the same shape and the same size, but their corresponding parts will be equal in measure. Okay, so that's kind of a good way to talk about it. Okay, so numbers are equal, or the lengths could be equal, but the shapes are congruent. Okay, so that's kind of a good way to talk. Okay, so let's talk about congruency. Segment AB, and normally like angles and segments, if you want to show that they match, it's like your socks. You put the same amount of stripes on. Notice that CB and FE have just one stripe on it. Okay, so if your socks match, you have the same amount of stripes on them. Okay, and like the angle B right here and angle E, those are going to be congruent because notice they each have 3 stripes on them. Okay, so that's how you show that things are congruent, is by matching their stripes. Okay, just like your socks can match. Okay, so if AB, notice, is congruent, it's 1.7 centimeters, it's the same shape and the same size as EF. So we could say segment AB, shapes that are going to be the same shape and size, can be congruent. AB is congruent to EF, segment EF. So yes, they're both segments and they are the same size. Okay, so those are congruent. And then we could say CD, segment CD, is congruent to GH. Okay, and we could put 2 stripes on those socks. Okay, there you go. So those 2 segments are congruent to each other. And so therefore, their measures are equal. So if I want to say, hey, the length of AB, how do I do it? I could write either the measure of segment AB, that's a lot of things, okay, equals, and I could say the measure of EF. I'm bored of saying that. How about if we just say the length of EF? Okay, those 2 segments are equal to each other and they both equal 1.7 centimeters. So lengths or numerical values can be equal, okay? Shapes could be congruent. You would never say that 2 triangles are equal. That's just weird, okay? Their parts will be equal in size, but they're, if they are congruent. Okay, another thing we would say would be the length from C to D is equal to the length from G to H, okay? And that equals 3.5 centimeters. Okay, and you don't have to do the part on the right, but I'm just saying, hey, look, numbers are equal, segment lengths can be equal, and shapes are congruent to each other. So it's kind of a good way to talk. And I want you guys to sound as smart as you are, Okay, betweenness, we've spoken of that before. If a point is between two other points, it implies that the 3 points are collinear with each other. Between doesn't mean halfway between. Okay, so don't have it mean more than it should. Okay, so if point C is in between A and B, it's just collinear with those. Okay, it's on a line that contains both those points. Okay. Segment addition, okay? So since segments have a numerical length, okay, you can measure a segment. You can do addition and subtraction of segments, okay? So we're going to be doing adding of segments to write equations and solve for x. It's going to be a really good time. And I forgot to say P and R are not. Let's see. Oh, yeah. Okay. On this diagram here, these guys, R is not between A and B, okay, nor is P, okay, so, all right, segment addition, back to that, sorry, back to segment addition. If you add up two segments, you would get the whole. Okay, so the sum of the parts equals the whole. Okay, so if there's a couple parts that make up the whole, well, then add up all the parts and you'll equal the whole. So what they're saying is, if you have a segment PQ, okay, what would you add up to get that? Well, if you add it up from P to R, this part right here, the parts, okay, you would get the whole. So if you add up this part plus this part over here, guess what you're going to get? The entire segment. Okay, so the sum of the parts equals the whole. So the length from P to R, okay, plus the length from R to Q would equal the length from P to Q. Okay, so we could use those lengths and add up the sum of those parts, the measure of each of those parts, and then we could equal the entire length. Okay. Another thing, vocabulary-wise, would be midpoint. Okay, the midpoint of a football game. What's that? What's halftime? Okay, so the midpoint of a segment would be halfway between two points. And what's implied is that, and maybe this is not true in a football game because of timeouts, etc., but these two lengths here will be congruent to each other. Okay, their lengths will be equal. Those two segments, AX and XB, will be congruent to each other. So if X is the midpoint of segment AB, well, then AX is congruent to XB. Okay, and therefore the length from A to X equals the length from X to B as well. Okay, and then also backwards. If you see a segment where the two halves of it are congruent, well, then you know that point X is exactly in the middle of it. Okay, so sometimes it's like, yeah, you could go both directions. Not everything is that case, but this is absolutely something that if you know you have a segment broken up into halves, into two congruent pieces, well, then you know what the midpoint would be. Okay. Now, if you're in class, I would definitely show you quite a demonstration right now. If you start with a segment, okay, segment AB, okay, because it has a measure, it can be broken in half. Okay, so if you have a segment from A to B, you could break it in half. How could you do that? Well, you'd use a segment bisector. So I'm going to take out my hand and do like a karate chop, okay? I'm going to ask, be like, has anybody chopped a board in half with their hand? I have not. I would probably break my hand, but somebody probably in the room has. And so we're going to say, if you have a karate chopping hand that you can break a board in half, awesome. Congratulations. That's really incredible. But you could have a point that breaks a segment in half. You could have a ray that chops in half. You could have a line that chops the segment in half. Basically, it's a knife or a karate chopping hand that breaks a segment in half. So a segment has a measure, and you can break it directly in half with a point, a ray, a segment, a line, etc. And this part right here, the thing that cuts it in half, is going to be the bisector. So that's kind of going to be the knife that chops it in half. Okay. Pardon me. Okay, so now for some math. Because we're talking about numerical values and segment lengths, we can do segment addition with those numerical values and solve this. So again, geometry is a bit of practice for Algebra 1. Okay, and there's a lot of words, but it's not necessarily word problems. You just have to know how to interpret what you see. Thankfully, there's not a whole lot of buying watermelons in geometry class. It's mostly like draw a picture and write an equation to solve for the missing value. Okay, so we have segment NO, okay, and it's comprised of NM plus NO. So the sum of those two pieces, those two segments, equals the overall length from N to O. So it says the length from N to O is 5x plus 2. We know NM is 3x minus 5, and M to O is 17. So in math class, as you know, we're going to write an equation and solve it. So if you take the sum of each part, so we're going to take 3x minus 5, and you're going to plus it to 17, and the sum of those two parts equals the overall measure of the entire segment. So it's be 5x minus plus 2. So I would ask if there's questions, but you're going to have to come talk to me if you do. We'll combine like terms on each side. So this negative 5 and 17 make 12. So we've got 3x plus 12 is equal to 5x plus 2. Let's show that we're putting all the x variables on one side by adding or subtracting the terms to move them to the same side. So I'm going to minus 3x from both sides. I get 12 is equal to 2x plus 2. I'm going to subtract 2 from both sides. And you're going to get 10 is equal to 2x. Divide both sides by 2. Using inverse operations, x is equal to 5. Now that you got to read the question, and say, okay, does it want x? Because in Algebra 1, that was pretty much your goal. Find x, for the love of Pete, find it again. Okay, but it says find N to O. Okay, so NO is equal to 5 times x and add 2. Okay, if we know x is 5, we're going to do 5 times 5, which is x, and then we're going to add 2. Okay, so it's 25 plus 2, which is 27, and label it. Okay, always label a numerical value. Okay, this is going to be units. Okay, so the length from N to O is equal to 27 units. Okay, awesome. Let's keep trucking. Point D is the midpoint. Okay, so read the words. Point D is the midpoint of segment EF. So here's E. Oops. Here is segment E. This is segment F. And right, not just collinear, but the midpoint is going to be D. Okay, so we know if you have a midpoint, it's the halfway point between those 2 points. So we know that this segment is congruent to this one. Draw socks. Okay, draw those hatch marks. Okay, to kind of count chickens. Okay, that's I think what they did to put little marks to count the chickens that were born. But you put the same amount of hatch marks on each segment to signify that those 2 segments have the same measure. Okay, so from E to D is 4x plus 6. And from D to F is going to be 7x minus 9. Well, sometimes you add up the 2 segments to equal the whole, okay? And that's what we did in the first question. But part of life is being able to say, well, based on this situation, what would I do now? Okay, and so the goal is to figure out all the different lengths, E to D, D to F, and E to F. However, now what we're going to do is say, well, how do you find that? Well, we know that if D is a midpoint, we know those 2 segments are equal in measure. So instead of adding them up and equaling the whole, which would be true but not helpful, we know that those 2 segments are congruent and equal in length. And so we're going to take 4x plus 6 and set it equal to the length of 7x minus 9 and solve that resulting equation. So let's minus 4x to get all the x's to the same side. We get 6 is equal to 3x minus 9. We will add 9 to both sides, and we'll get 15 is equal to 3x. Divide both sides by 3. Wow, this is getting a little sloppy. X is equal to 5. So look at your directions. Does it just want x, or does it want x? Oh, it wants all the lengths. Okay, so what we need to do is say, okay, let's find ED. Well, it looks like ED is going to equal 4 times x plus 6. Okay, so we do 4 times 5 is 20. And you add 6. So from E to D is equal to 26 units. Always look to say, does it tell you the numerical value in inches or centimeters? But it doesn't, so we say units. Okay, if we're living right, DF should be the same value, but I want to check to see if we did it right. So I'm going to say if X is 5, let's evaluate from D to F. So we do 7 times 5 and subtract 9. So it's 35 minus 9. So 35 minus 10 would be 25. So it'd be 26. Okay, so guess what? D to F is also 26 units. Great. And how would you find the length from E to F? Well, the sum of the two parts, which is ED to ED and DF together, is going to be 52 units. And that would be equal to E to F. So the measure of EF is 52 units. Look at us. We are getting stronger and smarter every day. Okay, let's check the next one. Points D, E, and F are collinear. Okay. Now, we don't know the order. Okay. But if D, E, and F are collinear, does E actually have to be between D and F? The answer is we don't know, okay? Not necessarily. Okay, so the thing is, just because D, E, and F are on the same line doesn't mean that it's in the right order, okay? They didn't tell us any order of how they have to go, okay? So it could be D and then F and then E. Okay, all collinear, all on the same line, but we don't know what order they're in, okay, or even which way the line is going. But the main thing is we don't know the order of the points on the line. Okay, if point E is between D and F, do they have to be collinear? Well, absolutely. Betweenness implies they're on the same line, okay? If they weren't between them, then it wouldn't work. So D, E, and F. So if E is between D and F, absolutely, yes, they have to be collinear. There's no other way. If E was not collinear with them, they wouldn't be directly between in the way that geometry means, okay? If E is between D and F, is E the midpoint? No, not necessarily, okay? Betweenness just means it's between it. It doesn't mean halfway between it. So don't kid yourself and be like, when they say it's between it means halfway directly. No. Midpoint says not only is it between them, but halfway between it. So using our vocabulary wisely. So E has to be between it. We don't know if it's halfway between it or just in between it. Okay, so likely it's just in between it. So what is the difference between AB and AB with a segment over it? Well, AB means the measure of AB. Okay, so the length from A to B. Okay, so the measure of A to B. AB means segment AB, which means the actual shape. Okay, so the shape AB is going to look like this. AB, okay? And so every point in between there, okay, and all the points in between A and B would be segment AB. The length of A to B will be a numerical value. Okay, so AB without anything on it says, what's the length between A and B? You would say 5 inches or, 25 feet. So that is going to be it. Well, I hope you have a great day. Thanks so much. Bye.